Okay, so before we talk about electrical charges, we need to understand what an electric field is. Before we talk about electric field, we're going to review what a gravitational field is. So, a field is an invisible area around an object that influences another object, puts a force on another object. For example, if I put a rock off the earth, it will travel along these lines. These are called gravitational field lines. It will fall towards the earth because the gravitational field of the earth acts on this test mass, a rock. The earth itself is the field mass, the mass producing a big gravitational field. The test mass produces a very small gravitational field, and so it's influenced by the field mass's gravitational field. So all these lines are called field lines, gravitational field lines. And there's infinite number of those. And it's just a path that the test mass will follow when released. And so the field is like an invisible force producer that affects a test mass. Okay, so let's now go to electric fields. First of all, there are two kinds of charges, positive and negative. Okay, so in this picture right here, we can see an electric field with electric field lines. So a charged object will have a force field around it that influences other, not masses, but other charged particles. Okay, so if you're negative charge, the force field lines draw a test charge. Test charge is always going to be a small positive charge. If you're a negative charge, you're going to have a field that draws a positive test charge into yourself, towards you. If you're a positive field charge, these blue and red balls are field charges. So if you put a test charge around the positive field charge producing, here's a positive test charge. Test charges are always positive. They will be repelled by the electric field. So like charges repel, whereas unlike charges attract. So here's another difference between gravitational fields and electric fields. Electric fields can attract or repel, whereas gravitational fields can only attract masses. Okay, so let's go on. Okay, now you know this, I just told you about this. So if you have the same charge, two charges that have the same charge, they're going to repel each other. And you can see the forces, we call that the electrical force, F subscript E. If you have opposite charges, they'll attract each other, and that you can tell that the electrical forces are pulling towards each other. Okay, a neutral object has no charge. That's what neutral means. Okay, by definition, you should learn this in chemistry. Anything with a positive charge has more protons than electrons. Protons are positive in the nucleus. Electrons are negative, spinning way outside, orbiting the nucleus, way far away, relatively speaking. Okay, so if you're a positive charge, you have more protons than electrons. If you have a negative charge, you have more electrons than protons. Okay, more on that coming up. Charge is quantized, meaning that you can only have integers of charge. You can have 1 plus, 2 plus, 3 plus, or 1 minus, 2 minus, 3 minus. Okay? So in chemistry, you talked about, for example, aluminum having a 3 plus charge, aluminum ion. Okay, that means aluminum has 3 more protons than electrons. Or aluminum ion, 3 plus, has 3 less electrons than protons. Okay, so here's an example. 5 neutrons, I don't really care because they don't affect the charge. 7 protons, 4 electrons. So 7 plus, 4 minus was the elementary charge. In E, that's what we call E. Well, it's really easy. 7 plus negative 4, because electrons are negative, equals 3. So the charge on that atom would be 3 plus. Okay, so that's one example. Let's do some more. Next page. -19. Okay. If an atom has 27 neutrons, I don't care about neutrons when I'm doing physics, charges. So 24 protons is 24 plus, and 26 electrons. Put a negative because electrons are negative, protons are positive. So you add those two, you get the elementary charge. So this would be -2. So this N would have a 2 minus charge. Now, in physics, we don't really use elementary charge. In physics, we use coulombs for charge. And 1 elementary charge is equal to 1.6 e to the negative 19 coulombs. So a coulomb is a huge amount of charge because 1 electron, 1 elementary charge is only a fraction of 1 coulomb. Okay, so aluminum ion has what coulombic charge in physics? So E equals 3 plus. So I'm going to say 3 times, that's 3E. Do some dimensional analysis if you want. E is 1.6 e to the negative 19 coulombs. Okay, so all I do is multiply the 1.6 e to the negative 19 by 3. So I get 4.8 times 10 to the negative 19 coulombs is what the charge of 1 aluminum 3 plus ion has. Now, if this was negative instead, if that 3 was negative instead, you just put a negative there, and your answer would be -4.8 times 10 to the negative 19. Okay, if a balloon's charge changes from -3 coulombs to -5 coulombs, how many electrons did the balloon gain? Well, he got more negatives, so he gained electrons. So how many electrons you gained? -3 plus what equals -5. So he gained -2 coulombs of charge. So -2 coulombs, change that to electrons. Coulombs to electron. Well, I'm sorry, I'm saying electrons, but that's elementary charge. Is 1.6 e to the negative 19 coulombs. So what I get from that is 1.25. Okay, this brings up an important point. That being that whenever something's charge changes, whether it becomes more positive, whether it becomes more negative, is because electrons are being lost or gained. The protons, you cannot give protons away. They're locked in the nucleus. So whenever something becomes more negative, it's because it's picking up electrons. If something becomes more positive, it's because it's losing electrons, not gaining protons. So a neutral ion, so you go from Fe neutral to Fe2 plus. You should learn this in chemistry. You lost 2 electrons. You did not gain 2 protons because protons are locked up in the nucleus. Okay, so we put a washcloth in the dryer from the washing machine. Okay, let's go to the next page. Sorry. After the dryer turns off, the washcloth now has a net charge of -5. Okay, so it goes from 0 coulombs to -5 e to the -3 coulombs. How many electrons did it gain or lose? Well, it became more negative, so it gained electrons. How many? Well, what I have to do is convert that to electrons. So -5 e to -3 coulombs. There's 1.6 e to -19 coulombs in electrons. 1 electron. So that's my answer. That's how many electrons this object, the washcloth, gained because it became negative. Okay, so we're going to have to do, this is a positive physics problem right here. So these are 2 metal balls. This ball on the left had that charge, positive 1.92. The other one has 4.8 coulombs. Now, when they touch each other, electrons will move from the more negative one to the less negative one. Okay, so the more negative one is equal to the one that is less positive. Okay, so this guy, electrons will move that way. So and if these balls are the same diameter, all that happens is that the total charge is conserved before and after. So 4.80 plus 1.92 equals 6.72 coulombs. That's the total charge before, but it also has to equal the total charge after. So, but because both these balls are the same volume, then each ball, it gets subdivided. Okay, this is the total Q. We use Q for charge. So that's the total charge before equals the total charge after. So, but we have two of them, so it gets subdivided. So each one is 6.72 divided by 2. 6.72 divided by 2, which would be, each one would be 3.36 coulombs. Now, this guy, the more positive one, oops. Okay, so, but again, the light green one on the left lost electrons to the dark green one on the right. I think I'll ask you that coming up. More positive one is the light green one. So electrons came from the electrons came from the less positive one because they had more electrons to the more positive one. Okay, so let me see this. Um, 1.92, 4.8. Okay, so what's the total charge on both objects before? Well, we did that already. 6.72 coulombs. What's the charge after? It has to be the same. Okay, so here's the answers right there. What's the... Okay, so it's from the more positive one. It's from the more positive one. Okay, so let's go back. So there's a net flow of electrons to the right. From the more negative one. In other words, from the more positive, from the less positive ball to the more positive one. Okay, so that would be this choice right here. What net charge was transferred from one object to the other? Okay, so they both were they were both what? 3.36 before. I mean after. This is after, but before, what were they? So to figure out how much charge went from there to there, all I gotta do is say, okay, I can either subtract these two or these two. So How did 1.92 become 3.36? Well, 3.36 minus 1.92. I'm getting 1.44 coulombs of charge of negative charge was given off by the left one. So again, 1.92, the more positive one, the less positive one, gave off what to become negative 3.36. It gave off 1.44 coulombs. So you could do it this way. 1.92 minus what equals 3.36. So negative question mark equals 3.36 minus 1.92. And so the question mark becomes 1.44, negative 1.44, because the negative is still there. So the guy on the left lost negative 1.92. The guy on the right gained negative 1.2. Lost 1.44. That's why my answer is that right there. Okay. Okay, so here we go. Here's another example. We can see what is the total charge on both after? Well, since they're identical, this has to be 6.56 coulombs as well. It has to be the same charge after they touch. So what plus and the total charge, the total Q, total charge is equal to twice 6.56. 13.12. So the total charge here has to be the same. So what plus 8 equals 13.12. So 13.12 plus 0.88 is 16. So this has to be 16 coulombs. Okay, so this is 13.12. What's the total charge? 13.12. Okay, so electrons have to move from the more negative to the more positive one. So this is an easy one because obviously negative 2.8 is bigger than any positive number, is more negative than any positive number. Negative 2.8 is more negative than any positive number. So flows, electrons flow from the more negative to the more positive. So right to left. What size net charge is transferred? Okay, so here's what we're gonna do. I don't know, maybe pick. It doesn't matter which one you pick. Let's pick this one. So you went from 16 to 6.56. 16 plus what equals 6.56? Well, we can see that the question mark equals 6.56 minus 16. So 6.56 minus 16 is equal negative 9.44 coulombs. So negative 9.44 coulombs was transferred from the right to the left. Okay. Okay, next big thing we talk about is Coulomb's law. This is the most important part of this chapter. Okay. So, here's Coulomb's law. You can see Fe is electrical force. Q1 and Q2 are the two charges. They have to be in coulombs. Don't use signs. That's why I have absolute value lines around Q1 and Q2. The two charges. R is the distance between the two object centers, or between the two objects that are tiny. Okay, so here's the first example. The distance between two charges is tripled. How would this affect electrical force? This is a what-if question. So if I put a 3 here, how does that affect this? Well, don't forget the squared. So it'd be 3 squared. It goes 1/9 of what it was. It decreases to 1/9 of what it was. If one charge tripled, oh boy, this is annoying. If one of the charges tripled and the other charge is half, okay, and the distance between the two, okay, so F equals K Q1 Q2 over R squared. So if one of them is tripled and the other one is halved, and the distance between the two charges decreases to 1/4, what does that do over to the force between the two charges? Well, 3 times 1/2 is 3 halves on top. 1/4 squared is 1/16. So basically, you can do that in your calculator. 3 halves times 16 over 1 would be 24 times more than it was. Okay? You could just do this on your calculator if you don't want to do the algebra. Okay, in this example, I want you to figure out what is the electrostatic force. Okay, so, wow. Okay, this is going to be crazy because this is in protons, this is in electrons. So E is -5 here because you have 5 extra electrons, and E is +9 here because you have 9 extra 9 extra protons. So Q, let's call this Q2. Q2 is equal to 9 e to the 9. That's what the K value is, times, oops, my fault. Reverse. Okay, so to change E to coulombs, what do I do? I multiply it by 1.6 e to the -19. Okay, so this would be -5 times 1.6 e to the 19. And this one will be the same thing. Q1 equals positive 9 times 1.6 e to the negative 19. Okay, now I'm going to plug in this equation, R. That's R, distance between them. So electrostatic force is 6 e to this. Oops, my fault. 9 e to the 9. That's what K is. Q1 is 9. 1.6 e to the negative 19 times 5. Don't use the negative on the numbers in front. Remember, absolute value. These are absolute value right here. Times 1.6 e to the negative 19, then all over 6.18 e to the negative 10 squared. Okay, that's pain. Comes out to 2.7 e to negative 8 coulombs. Okay? Now you should understand that that's the force of attraction between these two things. And these forces are equal but opposite directions. Okay? You don't say the bigger force, which would be this one, has a greater force attracting the other one than the other one does on the left one. Because Newton's third law, for every force, there's opposite and equal reaction force. Okay? Now, to tell you the truth, I'm not going to make you do this conversion when you have a Coulomb's law equation. I'm not going to make you do this conversion where you have to change the E to coulombs. I'm not going to make you do that, so this wouldn't even be in there, and it would be a much simpler problem. Okay, so I promise, I just threw that on so you could practice the other thing we just did. Okay, let's go to the next one. Let's see here. What direction is the force on particle 1? Well, they're attracting us to the right. And it's to the left. And we just found all this stuff, Newton's. You can look up K, I don't know. This is coulombs. This is meters. Actually, I can solve for what K is, the units. So K would be Newtons times meters squared over coulombs squared. And then I solved all those in another problem. These are equal because Newton's third law of motion. Okay, next. Okay, here's kind of give you on the exam too. Now, this is positive, so they repel. Okay, F equals what? K, Q1, Q2 over R squared. So K is 9 e to the 9 on your equation sheet. Q1 is 4.32. e to the negative 6. Q2 is 6.56. 6.56 e to the negative 6 divided by the radius squared, 1.21 squared. So I'm getting the electrostatic force to be equal to 0.0441. This is the kind of problem I'll give you on the test. Okay, the K is a constant. Always, it's 9 times 10 to the 9. Coulomb's constant. And these are the two charges. Don't use positive or negatives. Okay? And then, yes, on the power, but not in front of the number. Like, don't put the negative right here. Oh, there aren't any negatives, but if there were, don't use them. And this is in newtons. Okay, the force is always in newtons. I hope I did that right before. Okay, let's go to the next one. Okay, this one is the final problem, I think. Almost. Okay, so if I give you 3 of these, you gotta find the net electric force on sphere B. Okay, well, here's how I figure this out. I do it one at a time. Okay, so a minus and a plus attract each other. So I'm gonna put a force arrow like that for the force between A and B. And then, see, a negative and negative repel each other. So, I'm gonna put a repulsive arrow for both of these. They pull away from, so I'll call that FBC, the force of B on C, or the force of C on B. Okay, so you can see that they both go the same direction, so I'm just gonna find both those forces and add them, that's all. So what is it? B caused by A. So that was to the left. So I have to find that F equals K Q1 Q2 over R squared 9 e to the 9 times 8.17 times times negative 1.1, but don't put the negative in front of it, right? Negative 1.19 e to negative 6. All divided by the radius, 0.214 squared. Okay, I get that negative's not supposed to be there. Okay, I get for this force right here, the red force, I get 1.91. 1.91 newtons, and that's pointing, on the middle sphere is pointing to the left. Then I do the same thing for the blue one, the force between B and C. And so I'm going to do that work right here. F equals 9 e to 9 times B 1.19 times the other one, 6.95 e to the negative 6. Oops, this is negative 6 as well. And over the radius between those is 0.143 squared. So I get 3.64. So 3.64 newtons. And that one's also pointing to the left. Therefore, to find the net force, because they're pointing in the same direction, the net force is equal to 1.91 plus 3.64. 1.91 plus 3.64. I get 5.55. And then that would be pointing to the left as well. Okay, so that was kind of involved. Then finally, we got this problem. Now, when this guy releases this ball, it's going to just stay stationary because this is negative. It's repelling this ball. So here's the ball. Here's the free body diagram. There's the electrical force pushing it away from the, likewise, negative plate down here, charged plate. But the weight of the ball is mg. The weight of the ball keeps it from continuing to move upwards. So these two forces equal, so the thing is in equilibrium. So what direction is the weight force? Down, of course. What direction is the electric force? Up. Because negative is repelled by negative. Pitball. Pitball is just like a spitball, but dried. Ping pong ball, maybe. So what's the force? The electrical force. Well, F equals K Q1 Q2 over R squared equals 9E9 times negative 5.28 e to the negative 7. The charge plate is, can't read it, negative 1.12, but I don't put the negative, e to the negative 7 over the radius, the distance, that's what I'm looking for. That's the distance between them. So the electrical force has to equal the weight if it's stationary. So, okay, so that equals m times 10. I forgot to tell you that mass of the ball is, let's say, 0.00, let's say 0.010 kilograms. So the weight of the ball is 0.01 times 10, which is 9.8. Okay, so that's 0.1 Newton. So the weight of the ball has to equal the electrical force supporting it. So I'm going to put 0.1 here. So let's see how. So basically, I'm just going to cross multiply it. 0.1 R squared equals this mass. Then I get rid of the 0.1, divide both sides by that. And then get rid of the square by squaring with that. So this circle thing I'll just do right here, 9. Okay, you don't want to put the charges in there. I mean, okay, so 9 e to 9 times 5.28 e to the negative 7 times 1.12 times to the negative 7 power divided by 0.1. And take the square root of that. I get 0.073 meters. So that's the answer right there, which would have been the same answer as that. So electrical force up here has to equal the weight of the ball, which is 0.1. The K, these are all given. R is what we solved right here. Okay, so that should do it. We're done. Let me just double check something. Okay.